So here's the offending article. You can see if I just, I'll show you what it's doing. It's got 240 volts on this clip, so I have to be a bit careful. If I just put that on there and that on there, you can see it flashing? That's what it's doing at the moment. So there's something wrong with the electronics. I've had two of these bulbs and they've both gone after about 2 years probably. It's inside that lamp. So let's have a quick look inside anyway. I'm going to turn that off now because I don't want to get that up my shirt. There you go. So breaker open. This is the base that's come off. It's supposed to be on there, but I put a different base on it because it wouldn't fit in the light. Okay, so I've got a small controller here. Let's have a look, see what we can find. Okay, so let's have a quick look at this here candle light. You can see here's the LEDs, which are driven by a series of rows and columns connected around the bottom here of this flexible copper PCB with the LEDs on, and by modulating the rows and columns in a particular way by the micro down there. Can you see that? Can you see that? By that there micro capacitor, bunch of transistors to drive the rows and columns to boost the power output from the micro, and then some stolen code which probably was written once and then stolen 100 times so that all the factories could make this. And here it is, and then we have a thing here. Actually, you can't help wondering that, you know, these only last a couple of years because the design is absolutely pants in terms of reliability, of quality. It's just enough to get you over the hurdle so that you don't think, oh, it's so cheap, I can't be asked to go back to the supplier, the importer, and say, look, this has failed. This is the second one, as I say, I've had one of these. And yeah, you can't. I think a decent candle would do the job better in terms of a carbon footprint. But there you go. Here it is what it is. And you'll see there's only DC voltage, plus and minus, being fed in here. And either this is shorted and there's something wrong with this side, which is causing the power to dip out when the LEDs first come on, when it initializes, or it's going to be something in the power supply. And I suspect, because these are the components that are under the most stress, it's going to be the power supply, really, isn't it? Let's face it, don't you think? So what have we got? We got mains input here, nicely soldered. Lovely job. Bridge rectifier under there. So this is rectified mains on this capacitor, which will be something like 360 volts at normal UK mains voltage. Slightly higher here because we're next to a substation. And then power supply chip somewhere. Power supply chip. There it is. I wonder what that one is. ACT something, does that say? ACT 9501, Chinese chip, copied from the UK or American Power Integration or some little Texas chip. So that could have blown as well. So that's a usual soft point, because it is switching the high voltage. And you know, these don't have any varistors on them, so there's nothing to arrest any mains transients that come down the wire. So you know, you can get a surge and half the lights in your work stop working with these cheap Chinese lights, but the Osram and the Philips ones that I bought are still on. So I don't buy cheap LED bulbs anymore. I only buy Osram, really, and they just they keep their brightness, not being overdriven, and the EMC characteristics, they don't radiate lots of noise, and they're reliable. So in the event, they're actually cheaper to buy a decent Osram one than 3 Chinese ones. So anyway, yeah, so we've got the reservoir capacitor, which is manufacture of Nono or Mono. Is that Mono? Monk? Anyway, low ESR, yeah, right. 105 degrees, my price is 10 volts, 1000 microfarads. And then on the high voltage reservoir side, we've got this 6.8 microfarad 400 volt. All right. Now, that's quite small for a 6.8 microfarad at 400 volts. Firstly, I would say that is a very small capacitor. We'll check it against some real quality ones in a minute of similar spec, and we'll see what the physical size. Physically small capacitors for the voltage and capacitance are obviously indicative of corner cutting, really. You can see this one's nice and flat. Can you see the end of that cap there is flat? See that? And if you look at this one slightly, can you see that it's very slightly pushed upwards as though there's been pressure inside this? May not be the real problem, sorts the problem, but if this has gone open circuit, then you've got no reservoir regulation on the DC. So really you're feeding this chip with rectified DC AC mains, which is just basically 100 pulses a second. And it may not work, so it could just be one of these caps has gone. Oh look, yeah. A good look around's worth 1,000 probings with your meter. Can you see that? It's shit the bed there. Some of what's inside is on the outside, as it were, for now. So at the moment we'll change that cap, and it may well be the root cause of the problem. So let's get back to the other camera and change the capacitor and see what happens. There's a positive mark, yeah, it is. Oscillating, guys, I think this is the cause. Alright. So you can use an ordinary meter for this, or any other meter, but I'm just going to stick this on the old Mesh Tech. It's good enough for this kind of cap. There you go. So what's the positive and that's negative? That one, it's not really good to hold on to these actually. If you're touching the leads, you do get some kind of weird reading sometimes. Go. Yeah, 70 nanofarads. So that cap is basically open circuit. The juice has come loose and it's knackered it. So let's just put the lights back on. Stand by to be blinded. Now out. Put the lights back on. Get the capacitor box out, which will be down here. Okay, ooh, that is white. And there within is the marble of the capacitors. Get my other camera up. My Sony camera is so much better than this Panasonic one, but the power input jack got broken. Somebody, mentioned no names, tripped over the bloody wire. Right, so here we go. Here's a good comparison. Oh, lovely. Where's that shitty one gone? Right, there you go. So this one is a Worth Electronic, 400 volts, 3.3 microfarads. Now look at the size of it. Look at the size. You can see. Well, focus, you focusing thing. Look, see the 10 microfarad, or is it 6.8? 6.8. is the same size, pretty much damn near the same size as a Western 3, alright? So whether it ever was 6.8 or not, I don't know. But the thing to bear in mind about this is that you say, well, it's got a 6.8 in there, you should put a 6.8 back, but this is also specs run at 110 to 240. So in the good old American market, you've got half the voltage. That's where the big market is, and yeah, they're golden out there. They have a nice time, because it's not running anywhere near the same voltage. It's running at half the voltage actually that it's running over here. And so with a larger capacitance, lower voltage, you need more smoothing, but as soon as we're running at twice the voltage, we're going to be running at much lower current. So as a 240 volt implementation, I'm just going to stick this one back in and then see if it works, because clearly this has failed. And you think about this would have been thrown in my wife's favourite flaming lamp, which I'll show you when it's working. Inside the lamp, it's really quite sexy actually. Would have been thrown out for the sake of, this is probably in China a couple of cents literally, but obviously it's only worth a couple of cents because it's absolute crap. And whereas something like this will go on for years and years and years and years and years and years and years, this goes on for about 18 months and it poof, it's gone. and the whole bloody lot gets thrown in the bin. So how crazy is that? So where is my mother sucker? Where have you gone? Right, the mother sucker, or the soldier sucker, what do you want to call it? I call it something else normally, but I can't say that on the whilst broadcasting because I'll get struck off. So, Samuel L. Jackson says it a lot on quite a few of his films. Suck out one hole. While you're at it, you might as well suck out both holes. There we are. Obviously important to mop up all the little bits of solder that have been blown off during the sucking process. It usually can be quite messy, and you end up with bits all over the place, so you've got to check around to make sure you haven't left any bits sprayed around the place. You know what it's like. Okay, now tip on these capacitors, I can tell that, or immediately that's the positive lead, because the positive lead is always longer. And when they used to sit there, the women in Chinese factories used to sit there on a thing called a paternoster, where these rotating trays of components come round, and these would always be positive, so you can put them in without looking to see what it is. It's always the long lead goes down the positive hole, okay? So it goes in that way around. Come on. In you go. Here we are, and it's got to lie down flat on there, isn't it? So we've got to bend it. So don't solder it down like that, otherwise it won't go back together. Pull her down on it, and open the legs, spread them, and check the polarity again. Check the polarity twice and solder it once. Or as my dad just say, you complete plonker, what you're doing now. I just love doing these simple repairs. Will we be successful? That's the question. Right. Moment of truth. Moment of truth. Where's my snippers? Do you know what? I need to have a damn good tidy up in this place. Got my bloody snippers now. Oh, there they are. Put them back in the tray. Oops. Talking of quality products, you see these things. I've had these when I was 16. I left school because I couldn't wait to go out and get some money, and I worked in an aircraft instrumentation place where you had to buy your own tools, and that was well, 45 years ago probably. Look, and they're still going strong. And obviously when you can't find your pliers, everything's, well, you haven't got any pliers, everything starts to look like pliers, and you can see various things have been chopped and grabbed with this over the years. And if I could think of a good way of reconditioning these jaws, I would, because this is clearly very, very good steel. That bit slipped off a bit. Push it back on. But yeah, lovely piece of kit. But I think they're about, I think they're getting on 50, 60 quid now for a pair of these, but they're well worth it. They're very good. Right, so anyway, let's cut the crap. Where's the danger wires? Here's the danger wires. Right, shall we try it? Shall we try it? So I'll turn the... I've got 240 volts on these clips. It is isolated though, so in theory I could touch either one and not die. Not instantly anyway. Just, you haven't seen me, but I have got very curly hair. Or actually, alternatively, how about this? For a safety approach, we can just clip it on there, can't we? As long as we don't short out on anything else. Or can we? It's a little bit tight. One on there. And one down there. Come on, baby. There we go. Does that go at the same place? I'd hate to blow it up after immediately after I've fixed it. That would not be good. Bum, 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 bum. Right, we have contact. Right, okay. So let's turn the lights off. And contact. Yay! We have a flaming light bulb. Is that me though? That's actually flaming upside down, isn't it? 'Cause that's the bottom of the bulb. I see. It's supposed to go on a pendant hanging down. We've got some anti-flame. We've got anti-grav flaming going on because this is actually the top of the bulb if you stick it in a table lamp, and it's flaming the other way up. Never noticed that before. But I can touch it because I'm running on isolated mains at the moment, so I can touch it with one finger. And I've got rubber under trousers on. But yeah, it's working now, so it's just that cap of blown. That's quite effective, isn't it? Should we go to full mesmerisation mode? Put that there. Like that. Zoom in. Right, are you feeling are you feeling mesmerised? It's a licky flame. Right, back in the room. So there you have it. It's working. So that was just that poxy little capacitor that's caused us this problem. That thing there, half the size what it should be, never was any bloody good. Probably a cent or two. I'd rather pay an extra 10 cents for my thing, have a Nippon Chemicon or a Worth capacitor or something decent in there, and know it's going to last 5 years instead. So I shall stick it back in the light and I'll show you it working in the light because it is quite sexy. So here's the light working now. I've put the candle bulb back in. And you can see the colour of those amber LEDs work very well with this rock salt because it's kind of an orangey yellow colour. And in the evening it's quite a nice alternative to a fire because you get the flickering fire-like effects. It's almost like a small volcano in the corner of the room, and the light flickers across the room and you end up with quite an interesting effect. You can see it from different angles. Okay, yeah, that's a better look. It looks better now. It's more, I'd say, slightly flamier colour than that orange. That deep orange there is really the camera. I wonder if it's this that's doing it. But in real light, it's a kind of a lighter yellow, more of a flame yellow. But the other thing it's got is this feature, or function, or you want to call it. If I let's come around this side, and then if you switch it on, off and on, it just turns into an ordinary rock light. Flick it again. You can see it strobing on the picture. It's beating with the camera rolling shutter, the lights, but I can't see any flicker at all. You can see it gets brighter, and then it gets dimmer, and it varies in brightness. Flick it again, and you're back into the old flicker mode. All right, so I hope you found that interesting, but that's it, a modified rock salt light. If you can, then hit the little titty button down in the corner and subscribe if you like it, and leave me a like. Thank you.